Hello good day viewers, into this tutorial we are going to see the diode circuit exercise. Into the last video we introduced the electronics and some definitions on the electronic semiconductors and diodes and Zener diodes and LED. So we shall see the exercise one by one. The first question, it says that we are to determine the VO1, V01, the V output 1 and the V output 2. So if we take a look at the circuit, and this is a voltage, and this is the resistance, and this is also another resistance, but this is a node because we have the V out 1 here, and therefore we also have V out 2. But this is the same thing as writing, this is the same thing as saying that, I have this is source of ground. This is the same thing as having VO2, the V naught, the second V naught. But we all know that this voltage, because we have this is silicon, as we all know. So therefore I have to delete the silicon, because we all know that the silicon is the same thing as 0.7 voltage. So therefore, since this silicon and this voltage are in parallel, so therefore the voltage have to be they have to be the same, but the current, it is not the same. So therefore currently I have to say that my VO2 should now be equals to 0.7. the same thing as this, because this is VO1. So therefore also the VO1 should now be the VO1 should now be equals to 0.7, because they are in parallel. So therefore the V02, it is now be equals to 0.7 voltage, and therefore the VO1 also, it is 0.7 voltage. So therefore this is what we find in the V out 1 and V out 2. So the next we are asked to find the current. So as you all know, the current in this circuit, in this circuit and this mesh and this mesh will not be the same. So how can I can say that if I am to find the current in this look, I will say the V divided by V divided by R, and we all know that what is V? V is the same thing as, I shall now be equals, how many voltage do we have here? We have 2 voltage. So therefore 20 minus minus this 0.7 divided by divided by 1 times 10 to the 1 times 10 to the power of 1 times 10 to the power of 3, which is 1 kilo ohm. So we use the Ohm's law. So therefore this minus this, I shall now get 19.3 divided by divided by 1000. So therefore this shall now be this shall now be 0.0193. so therefore this is the current in the cycle. So let me check whether 19.3 divided by 1000, yes, it's the same thing as 0.0193. So this is now equivalent to the value of the current should now be equals to 19.3 milliamps. But this is not only the way that I can use the second way. If I am to use the second way by using the KVL, what should I going to get? I'll get the same answer. So now the current should now be, the current in this mesh should now be 19.3 milliamps current. So there is one thing that I want you to know, is that whenever we have negative to positive, it will drop. What is drop? Drop, it means negative. And therefore whenever the positive towards negative, it will rise. Rise is rise is positive. So let me show you what this means. If I am to use the KVL to find my current from negative to positive, it will drop. So therefore I will have negative 20. So therefore I have to say, since from negative to positive, so therefore shall now be from positive to negative. From positive to negative, it will rise. So therefore I'll have plus but I have the current through this resistance. So therefore I said the current multiplied by multiplied by 1 kilo ohm, and therefore what is the value of this voltage? This voltage should now be what? Should now be silicon. The VO1, which is what? 0.7, and therefore it is what? It is rising. So therefore I will say what? I will say plus what? 0.7. So the next thing that I'm going to do is that I have to say minus this plus this. Minus this plus this, I'm getting what? Minus 19.3 plus what? Plus 1 I1. 1 multiplied by 1, it is the same. I multiplied by 1, it is the same thing as what? I what? I, but with what? But with kilo ohm. So I will say I multiplied by 10 raised to the power of what? 10 raised to the power of 3. This is the same thing as writing 1 times 10 to the power of negative 3. So therefore all this should now be equals to 0, should now be equals to 0. So the next thing is that I have to say that the negative 19.3, when this I turn back to the equal sign, when it crosses the equal sign, it will now be what? It will now be a negative what? The negative I. So therefore if I divide both sides by what? But don't forget I have what? Kilo, but I have to eliminate the kilo. If I eliminate the kilo, at the end I will have what? Milliamps. But if I go with the kilo, at the end I will end with what? 0.00 something. Then I can convert it to what? To milliamps of current. So therefore if I divide both sides here by what? Negative 1, this will cancel, this will, the negative sign will cancel. So therefore the value of the current 1 in this mesh should now be equals to what? Should now be equals to positive what? 19.3 with the kilo, which will now become milliamps of what current. So this is the current that is what? That is passing through this 1 kilo ohm resistance. I mean the current in what? In this mesh. But if I am to calculate the current in this what? In this mesh, what should I do? So therefore I have to say that my I1 is the same thing as 19.3 milliamps of what? Milliamps of current. So therefore you can use the two methods. Either you can use Ohm's law, which is V divided by what? V divided by R. So therefore you have to use the voltage minus what? Minus what? Minus your diode what? Diode voltage, which is what? The silicon. And therefore you have to divide by what? By the resistance. So therefore you can also use the KVL, which we did here. So therefore the next thing to find, we have to find the current through what? Through this mesh. So therefore if I'm to find the what? If I'm to find the current in what? In this mesh, so the current will go here. You have to check the direction of what? Of the current. I'll have 0.7 what? Minus what? Minus 0.75 minus what? Minus this diode, which is minus 0. What? But I have my current here because I'm looking for the current multiplied by I1, and therefore what? I have to say minus what? Minus this diode, which is 0.7. All will be equals to what? Equals the source of ground, which is 0. So therefore, as you can see, I have what? This will go with this because I will say 0.7 what? Minus 0.7. So therefore it should now be what? 0. So I'm left with 0.75 of current multiplied by what? Multiplied by I1. This should now be equals to what? Should now be equals to 0. So the next thing that I'm going to do, I have to divide what? I have to divide both sides by what? By negative 0.47 by what? Negative 0.47. So this should now delete with this. So therefore I will end with what? With the current what? With the current I2. Sorry, with the current one. With the current I2, 0 divided by this, it will give me what? It will give me, definitely it will give me 0. So therefore this should now be what? 0 amps of current. So if I said 0 divided by what? Negative 0.47, so this shall now become 0. So therefore I will say the total current in this circuit should now be 19.3 milliamps from what? From 0 amps. So therefore this should now be what? My new current now should now be 19.3 what? 3 milliamps. So this is all I have for you for the first question. From the circuit, we are to determine the what? The value of V0, and therefore we are to determine the what? The current diode. So how can we determine these two values? So the first thing that I'm going to do, I will just take a look to this current and this resistance and this resistance. They are both in what? In parallel, because it is the same thing as having what? Having this, and therefore I'll have what? I'll have my voltage like this. So, but you have to remember the source transformation. The source transformation, let me draw this circuit. I have this, and therefore I have what? I have this current in parallel to what? To this. This resistance is parallel to this current. So therefore I have to apply the source transformation, 10 milliamps. So if I apply the source transformation, this is what I have current as what? Current as 10 milliamps, and therefore the resistance at what? 2.2 what? 2 kiloamps. So therefore V it is equals to what? V it is equals to IR. The current should now be 10 multiplied by the resistance, which is 2.2. So therefore this should now be what? 22 what? 22 volts. So as you can see, I can delete this. I can delete this and say I have what? I have a voltage. The voltage, is it rising or dropping? So therefore it is what? It is rising. So therefore I'll have what? I'll have 22 voltage, and therefore I'll have what? I'll have again my resistance. I'll put the resistance that I multiplied by what? That I multiplied by 10 to get what? To get this 22 voltage. So therefore the resistance should now be what? 2.2 what? Kilo ohm. And therefore the value of the diode, as you can see, the diode it is on or off. This diode it is what? It is on. So therefore I have to change what? I have to change the circuit. This as what? Positive, and this as what? This as positive, and this as what? This as the negative. So the next thing that I'm going to, let me just clean this. This is the same thing as this, and this is the same thing as this. So as we find the voltage using the source transformation, the next thing that we are going to do is that we have to first identify the diode current. How can I find the diode current? I have positive, I have negative. You have to recall this, that minus to positive, it is what? It is dropping. It is dropping, and therefore positive to what? To negative, it is what? It is rising. As you can see, I have negative and I have positive. Negative to positive, it should now drop. Minus what? Minus 22 volt. Positive to negative, it should now be what? Positive, it should now be what? Rise. So plus 2.2, and therefore positive to what? Positive to negative, it will now what? Rise. So therefore plus what? Plus 0.7, and I have to come across, and therefore I have what? I have ID, which is what? Which is the current. So therefore I have in each of it, or let me say, I have to say plus what? It will come across what? Across here, but it will first go to what? Go to this resistance. So therefore this should now be 2.2 multiplied by what? By ID, and should now be equals to what? Should now be equals to 0. So the next thing that I'm going to do is that this and this I will now get what? Minus 21.3. So this and this I will now get plus what? Plus 4 ID, it is equals to 0. You have to know that in each resistance we have what? We have the current. We have current. So therefore I can say this what? This as what? As I can set it as what? 2.2 ID, and therefore again the resistance what? 2.2 ID. If I sum them, it will now be 4.4 what? ID, which is what? The current diode. So this is the same thing as saying 4.4 ID should now be equal to, when the negative 21.3 cross the equal sign, it will now be what? 21.3. If I divide both sides by 4.4, this will cancel this. So therefore the diode current should now be what? 21.3 divided by 4.4. 21.3 divided by 4.4 should now give me what? If I say it's 21.3 divided by 4.4, this should now give me what? 4.8 what? 4.84 milliamps. So therefore the diode current should now be what? 4.84 milliamps. So the next thing is the voltage. The voltage out, the V out. So therefore I have to say that this V naught when this V naught rise, so therefore what, the resistance will drop, so it will now be negative 2.2 what, ID should now be equals to the source of ground, which is 0. So if I said this V naught should now be equals to 2.2 what, ID, so therefore the V naught should now be what, 2.2 multiplied by the ID, which is this, so 4.8 what, 84 milliamps. The V out should now be what, if I say that 2.2 multiplied by 4.84 milliamps should now be what, should now be 10.6 what, 0.65 voltage. So therefore the voltage should now be 10.65. So this is all I have for you for the second question. So we are to determine V naught and ID in what, in this figure. So this is not much hard, but it is easy because we are going to use the KVL or what, or another method that if we are to find the current, we shall say the V divided by what, V divided by what, the value of R. So as I said in the last video, negative to what, to positive, it is what, it is dropping, positive to negative, which is what, which is rising. So therefore I can apply the KVL if I like. I will apply this. So but the next thing that I'm going to do, I have to say, let me use the KVL because, but this 8, it is what, it is rising, so therefore the rest will be what, will be dropping. So I'll have positive 8, so this should now be what, negative this 1.2 what, ID, because each resistance will have what, will have its currents. So therefore we are looking for the ID, so therefore I have to say minus what, minus 4.7 again ID, and therefore I have to say minus what, minus 0.7, which is what, the silicon diode, which is the same thing as 0.7, and therefore I have what, this should now be equals to what, it should now be equals to negative what, negative 6, this source of ground. So the source of ground now, it is what, it is given as what, as its voltage, which is what, is minus 0.6. so therefore this should now be equals to 8 minus what, minus 5.9 ID minus 0.7 should now be equals to minus 6. So therefore this should now be, this and this, they are like terms, so therefore it will now be 7.3 minus 5.9 what, ID should now be equals to minus 6. So therefore I have to say minus 5.9 ID should now be equals to minus 6 minus, so when this crosses the equal sign, it will now be negative. As you can see, this is positive. When it crosses the equal sign, it will now be negative 7.3. So therefore this should now be minus what, minus 5.9 ID. This should now be equals to what, if I said minus this minus it, I'll get what, this is 7 plus what, I'll get 13, negative 13 point what, negative 13.3, because if I said minus 6 minus again 7.3, it will give me 13.3. If I divide both sides by negative 5.9, divide both sides by negative 5.9, this will cancel this. So therefore the ID should now be equals to, this negative will cancel this negative. If I say divide by negative what, 5.9, this should now be equals to, okay, let me correct it. I have to say 13.3 divided by 5.9. So this should now become what, 2.25 what, milliamps. Because of this kilo, we are excluding the kilo. If you exclude the kilo, so therefore you will get what, in milliamps. But if you didn't exclude the kilo, so you get something like 0 point something 0, then 225. So now if I am to use the next method, what should I going to do? I have to say that this 8, which says that the ID, it is equals to V by R. So this should now be equals, how many voltage did I have? I have this voltage, so therefore I will say this is what, this is 8 voltage, it is what, it is rising, so therefore this will what, this will drop at 0.7, and therefore this is what, this is negative. So when this is negative, it will what, it will rise, so therefore it will now be what, plus what, it will now be plus, because if I said 8 minus 0.7, when this, it is equals to it is equals to what? It is equals to minus 6. So this should now be 8 minus 0.7, and this, when it throws the equal sign, it will now be plus what? 6, and therefore this is equals to 0. So if I say this minus this, I will get what? 7.3. If I say 7.3 plus 6, I will get what? 13.3. So therefore plus what? Plus 6 divided by the sum of the resistance, which is 5.9. So the sum of the resistance, which is what? Which is 5.9. This should now be equal to 13.3 divided by 5.9, which is the same thing as what? The same thing as this. So this should now be equals to 2.25 milliamps. So you can use this two way as I said in the last video. So let me find the V naught. If I am to find the value of V naught, what should I do? I will come across this. So this should not, don't forget I have negative 6. So I will set V naught minus what? Minus 4.7 ID. This is ID. Minus 4.7 ID minus what? Minus 0.7 should now be equals to minus 6. So I have to say this V naught minus what? Minus 4.7 multiplied by ID, which is 2.25. Which is 2.25, and therefore minus 0.7 should now be equals to what? Should now be equals to negative 6. If I said minus 4.7 multiplied by 2.25, what should I get? So therefore this should now be equals to V naught minus what? 10.56 minus 0.7, which should now be equals to negative 6. So minus this minus this. So I have to say minus 10 minus 10.56 minus 0.7. So this should now be V naught, it is equal, V naught minus 11.26 should now be equals to minus 8. V naught should now be equals to minus 8. When it equals to, when it was cause equals to, it will now be plus 11.26. V naught should now be equals to, if I said minus 6 and plus 11.26, so this should now be what? Should now be equals to, the V naught should now be equals to 5.26 volts. So this is all I have for you for the third question. It says we are to determine V naught and what? An ID. So as usual, we have to apply what? Either KVL or what? Onyx method. But let's use ID, which is equals to what? ID, it is equals to V over what? V over R. This should now be equals to what? I have voltage, this 20 minus what? Minus the silicon voltage 0.7, and therefore plus what? Plus this 20 divided by what? The total resistance, which is 6.8. So therefore if I say 20 minus what? Minus 0.7 and what? It will give me 19. So therefore I will say the plus what? Plus 20. So this should now be what? 39.3 divided by what? 6.8 divided by what? 6.8. So this should now be what? 5.78 what? Volts. So let's use the KVL. The KVL, this is what? Rising, so therefore it will now be 20 minus what? Minus 6.8, and therefore minus 0.7 again, which is what? The silicon voltage. And therefore as you can see, this diode is what? The diode is on. So therefore this should now be what? I have what? I have ID here. This should now be equals to what? Negative 20. So therefore this and this, it will give me what? It will give me what? It will give me 19.3 minus 68.8 ID. This should now be equals to what? Minus 20. So as you can see, minus what? Minus 6.8 ID minus 20. When this cross the equal sign, it will now be what? Negative 19.3. So as you can see, I'll have negative 6.8 what? ID should now be equals to minus 20 minus 19. 20 plus 10, 30 plus 9, 39.3. But I have minus. So if I divide both sides by this, I will end up with what? ID, it is equals to 39.3. The minus will cancel minus. So therefore divide by the value of what? 6.8. So as you can see, this is the same thing as this. So I already tell it in the second video that we solved the second question, that when you use this and KVL, it is all the same. So therefore if I am to find the V naught, So therefore, if I am to find the B naught, I'm looking for this. So this should now be equals to what? The 20 minus what? Minus 6.8 ID minus V naught. So therefore, this should now be equals to what? I have to say 20 minus 6.8 multiplied by 5.78 as our value of what? Value of current. So this should now be equals to V naught. V naught, it is equals to 20 minus this multiplied by this. I think it will give me what? 39 point something. Let me say 6.8 multiplied by what? 5.78. So this should now be equals to 39.30. So as you can see, V naught should now be equals to, if I say this, if I say 20 minus what? Minus 39.3. So this should now be negative 19.3. So if I am to use the V naught, it is equals to IR as usual. What is the value of I? The value of I, which is what? 5.7878. So if I am to say multiply by the resistance, which is what? Which is 6.8. So what should I go in to get? So I have to say it will now be 5.78 multiplied by 6.8, which is 39.3, and therefore subtract with this what? With this 20 voltage. So if I said minus what? 20 voltage. So wow, it is the same thing as what? 19.3. So you can use two ways to identify the V naught, and you can use two ways to identify the current. You have to take note that if you are going to find current using the I, it is equals to V over R. If this one, it is what? It is negative. So therefore at the end, after you subtract the voltage there, so you have to add it. But if you are going to find what? The V naught, in this V naught, it is equals to IR. After, when this it is positive, so therefore you have to change it to what? Negative. After multiplying with the result, you have to what? Subtract with 20. So this is all I have for you for the fourth question. Here is the fifth question under the diode circuits. As you can see, we have two silicon. So we have to take a look. The diodes are on or off. So therefore, this is what? This is the silicon diode. We all know that the silicon diode is what? 0.7. And you have to take a look to the diode. They are what? They are looking forward. So therefore, this are what? This is what? This is the forward bias. Forward bias what? They are forward bias, not reverse bias. If they are reverse bias, it means they are off. But since they are forward, they are what? They are on, because they take a look to what? To that direction, because they are taking their direction. So therefore, the value what of the germanium? The germanium, it is 0.3. So again, all the way we are going to use what? Let's use the KVL method. So therefore, you have to take note that, but they didn't specify this is rising or what? This is rising or dropping, because in the last question they specified this as what? Positive. So therefore, but we all know this is what? This is rising. So but we can say, let's use, we have negative to positive as what? As dropping, and positive to negative as what? As rising. So let's use this what? Positive to negative, because we all know it is positive. So let's use the what? Okay, it is positive to negative. If we use positive and the rest to be dropping, and we use 12 voltage as what? As dropping, the rest will be rising, it will give us the what? The same answer. But let's check for what? For dropping. When this it is dropping, it will now be what? Negative 14. Please, you have to take note that you can use any method, and therefore it will give you the same answer. Please don't be confused of this. So this should now be plus what? I have 0.7, and then I have to say plus what? 0.3. I have to say plus what? Plus this 2 kilo ohm, plus what? Plus this 10. So I have to check. Okay, this is it kilo ohms, or this is 10 ohm, not kilo ohm? So therefore I have to say yes, 10 ID, because I'm looking for what? I'm looking for the current. So therefore this should now be equals to 0. So if I said minus this plus this plus this, we all know that minus 12 plus this, it will give me what? 1. So therefore plus what? 2 ID plus what? 10 ID should now be 0. Minus this plus this minus 11 plus what? This and this, it will give me what? But yes, it will give me what? 12. 10 plus 2, it will give me 12. ID, this should now be equals to 0. So I have to say minus 11 should now be, okay, I will just keep what? 12 ID as it is. So this, when this cross the equal sign, it will now be 11. Divide both sides by what? 12 by 12. 12 will cancel 12. The value of ID should now be equals to, if I said 11 divided by the value of 12, I'll get 0.91 what? 916 milliamps. Because of what? Because of this kilo. So I have to put what? Milliamps. Yes, but you can put 0.91 what? 7 approximately. So therefore the ID, it is equals to this what? Milliamps. So the next thing that we are going to do, we have to determine this V naught. So therefore this V naught minus what? When it comes here, minus 10 10 ID should now be equals to what? 0. So V naught minus 10 multiplied by what? 0.917, it is equals to 0. So this V naught, if I said minus what? Minus 10 multiplied by 0.917. So this should now be minus 9.17, it is equals to 0. V naught, it is equals to what? 9.17 what? 9.17 volts. So this is all I have for you for this. But if I am to use what? If I am to use the what method? If I am to find the current directly by V over what? R. So I have to say what is V, which is 12 what? Minus 0.7 minus again 0.3. Divide by what? Divide by the sum of this resistance, which is 12. So this minus it will give me, first it will give me 1. 12 minus 1, it will give me what? 11 divided by what? 12. So therefore, as you can see, yeah, it gets back to this 11 divided by it will give us the same. So dear student, I'm advising you that when you are solving this kind of problem, kindly use the two methods. If one method give you the same, you follow the another method, it will give you the same. It means you are right. There is no doubt on your work. So therefore, please take note on this. Determine the VO1, the VO2 in the figure. If you could recall, I think in the second video we talked about how to find the V01 and the V02. So if we are to find the V01, we are going to start from here. We are going to stop from this what? VO1, because we are looking for it. For VO2, we are going to start from here, and therefore we are going to stop here. But you have to take note that the question does not say to find what? The current. So therefore, no longer finding current, we are just going to determine VO1 and VO2. You have to take note of that. So therefore, you have no business with what? With current. So how can I do that? As I said in the last video, this is given as what? It is rising. If you like, you can use this negative to positive as what? As dropping. Positive to negative as what? As rising. So this is given as what? It rise. If I like, I may change it to drop, but let me leave it. But some might say, let's try and what? Drop it and see. So let's drop it and see what are we going to get. You all know that if we drop this, if we drop this to a voltage, so the rest must what? Must rise. So therefore plus what? 0.7. The silicon diode, it is 0.7. And take note, gallium arsenide is 1.2 gallium arsenide. This is gallium arsenide, this diode. So therefore I have to say minus what? Okay, sorry, plus what? Plus VO1, it is equals to 0. So I'm stopping here because I'm looking for the B01. So this should now be equals to what? If I say this and this minus this plus this, I'll get 11 minus 11 point what? 0.3 plus what? Plus BO1, it is equals to 0. I'll keep this BO1 aside. This should now be 11.3. So therefore, I find BO1. So what of BO2? I'm going to start here. So therefore, the VO2 minus what? Minus gallium arsenide, which is 1.2, should now be equals to 0. So the VO2 should now be equals to, when this cross the equal sign, it will now be 1.2 volt. I have to put volt. This is all I have for you for this question, because it is very easy. You have to take note that there is no more current, because the question doesn't ask for currents. So therefore, you don't have to what? You don't have to insert current or do something else. If you are to find the current, you are going to use from here off to here, if you are going to find current, but no need of finding current. Here is the 7th question. We are to determine VO1 and VO2 in the figure below. So you have to take a look to this. We have to check whether this germanium, it is what? It is on or off, and check this silicon, it is on or off. As you can see, we are given what? We are given drop. That are showing this is drop, and you all know that this is what? Our diode. This is a PN type, this is a what? This is the N type. So therefore the PN type is the positive, and therefore the N type is what? Is the negative. So as you can see, negative, it is coming through here. So this is showing that negative will not be at here. When negative be here, so it means that is what? The diode is off, it is reverse. So from this figure, I can say this diode, it is what? It is off. So I'm left with only this one. I'm left with only this what? I'm left with only this diode. This diode will now be what? Will now be on. So, but can I be able to find the voltage one through this? Let's take a look to this question and see. There is no way to find the value of V1. The value of V1 will be automatically 0. So why? Why should it be 0? Because if this diode, it is off, so therefore this means that there is no more current that is flowing through this circuit. Take and notice this. There is no more current that is flowing through this circuit. Because if there is no more current flowing from here, from this VO1 to this, there is no current. So therefore, as you can see, the VO2, because this is what? This is not a diode, this is a resistor. It is a resistor, so therefore it should be 3.3 multiplied by what? By the current, which will now be 0. So the VO2 should now be what? 3 multiplied by 3 multiplied by 0. So the VO2 minus 0, it is equal to 0. The VO2 should now be equal to 0 volt, because there is no current flowing. So since there is no current, I have to multiply by what? By 0. So therefore also the V2, it is what? It is 0 voltage. Because there is no current that is flowing through this circuit, because this diode affects this. When this diode, it is off, it means no more current flowing in the circuit, and therefore the same thing, there is no current flowing in the circuit, because I am substituting the current in here so that I should find the V what? The VO2. So this is what? This is all I have for you for this question. So therefore the value of this V1, V01 and V02, or V output 1 and V output 2 are what? Are 0 volts. Take note of this. How to determine the ID and V0 of this parallel circuit. So this is another question that is different from the 7th question we did. So how can we determine this? You have to take a look to these diodes, 2 diodes, and first check are they on or off. The silicon diode, it is what? It is 0.7. The gallium arsenide, which is 1.2. So you have to take a look to this circuit. First diode move here, and the first diode move here, and therefore they go to this what? To this point. So it is possible that this diode will pass here, and therefore this diode must go here. Is it possible the 2 diodes at the same time will move to what? Will move to this V out, and therefore will go to what? Will go to this resistance? Is it possible? So this will not be possible. This must be what? This must be off, because this 1.2, it is more higher than what? than this 0.7, and this 0.7, it is more less than this 1.2. So therefore there is no possibility of this gallium arsenide to be on. So therefore this gallium arsenide diode, it is off. You are just going to concentrate on this diode, which is on. After then, you're going to apply the KVL, move here, and move off to here to find your currents. And therefore, if you are going to find voltage as usual, move to here. So how can I find this? So let me use the drop, negative to positive, which is dropping, and positive to negative, which is rising. So I have to say this is when this is dropped, the rest will be rising. So therefore plus the 0.7 the diode, and therefore plus 4.7 ID should now be equals to 0. Minus this plus plus then I'll end with minus 11.3 plus 4.7 7 ID should now be equals to 0. So I have to have 4.7 ID. This should now be equals to, when the negative 11.3 cause the equal sign, it will now be 11.3. So if I divide both sides by 4.7 by 4.7, 4.7 will cancel 4.7. So therefore the diode current should now be equals to 11 divided by the value of 4.7. What should I get? So let me check. 11.3 divided by 4.7. So this should now be the current should now be 2.4 watts. Because of this kilo, it is milliamps. You have to understand, if you are using the kilo, it will end up with 0.000 something, as I explained in one of the last example. So therefore, if you will exclude the kilo at the end, you come and use the kilo. So therefore the kilo, you now inside milli, it's the same thing as milliamps. So how can I determine this voltage? The V out minus minus 4.7 ID should now be equals to 0. So the V naught minus 4.7 multiplied by 2.4, it is equals to 0. So therefore the V naught minus this multiplied by multiplied by negative, let me refresh it, 4.7 I have negative 4.7 multiplied by 2.4. So this should now be equals to minus 11.28, which is equals to 0. So therefore the V naught should now be 11.28 11.28 volts. Determine the V naught and ID. As usual, as I am saying, you have to first take a look to the diode. We have the germanium as 0.3. We have the silicon as as 0.7. So you have to take a look. This it is specifying this is positive. So therefore, when the positive comes here, it will comes. As usual, we all know this terminal it is positive, this terminal it is negative, and therefore we know this terminal it is negative, this terminal it is positive. So therefore, when the positive comes, it will rely on here. So therefore, as you can see, the direction of this diode, as this is the PN type and this is this is the N type. This is the P type and this is the this is the N type. So therefore this diode will now be will now off. So therefore this diode it is on. So therefore I will use this diode. I'll come across it. But you have to take a look that in the last videos we are finding we are finding the ID current first. So let's first take a look. Let's drop this. It will be it will be negative 20 plus plus this 0.7, which is the silicon, and therefore if we come across here, so this should now be plus plus V naught, it is equals to 0, because we have a point here. So therefore we have B naught. So we have to stop here. It is showing you that we are going to first find the B naught. So therefore this minus it will give me 19.3. It is minus 19.3, and therefore it will become V naught it is equal to 0. So V naught will V0 will keep as it is. So therefore, when the negative 19.3 cross the equal sign, it will now be what? 19.3 what? Volt. So as you can see, we find what? We find the value of what? V0 first. So to find the value of what the ID, I have to start from this V0 up or down. So I'll go down. So therefore, this V0, when this rise, the rest will what? The rest will drop. And when this drop, the rest will rise. So let's say this should now be equal to the sum of this 2.2 plus what? 2.2 ID plus 4. Please don't be confused. If this is rising V0, so the rest will be 2.2 ID plus what? 4. If this what? It is rising, the rest will drop 2.2 what? ID minus what? 4. All is the sum of what? 0. So you can use 1 of 8. So therefore, this should now be automatically, because I have 19.3, which is equals to what? 2.2 ID plus what? Plus 4. So I have to say I'll keep down this 2.2 ID. This should now be equals to 19.5. When this crosses the equal sign, it will now be what? Negative what? Negative 4. So therefore, the 2.2 ID should now be equals to 15.3. So therefore, the ID should now be equals to 2.2 divided by this. Okay, sorry, 15 divided by what? Because I'm dividing both sides by 2.2. 2.2 divided by 15.3. Okay, sorry, 15. Let me divide in both sides by 2.2 by 2.2. This will cancel this. 15.3 divided by 2.2. So this should now be what? 6.954 what? Milliamps. So this is all I have for you for this question. Determine the V0 and ID. So again, the same to the, I think the 8th question that we did. We have gallium arsenide and silicon. Yes, as we can see, this is the gallium arsenide. Gallium arsenide as 1.2 and the silicon diode as what? 0.7. So which of the diode it is on or off, or are they on all, or they are what, or they are off? So as you can see, this diode is what? It is on, because at the same time we can't have what, because this gallium arsenide, it is what? It is much higher than what? Than this, and this silicon diode, it is what? It is very less than what? Than this gallium arsenide. So therefore, automatically this will now be what? It will now off. It will now be off, so that we can what? We can find the current in what? In the circuit. So the next thing that we are going to do, we have to say, if we use the drop minus 1 plus what? Plus what? Plus 0.7 plus 0.7, and therefore we have to stop at here. Plus what? Plus V0 should now be equals to what? Should now be equals to 0. If I said minus 1 plus what? Plus Z, what shall I going to get? It's the same thing as saying this minus Z, so therefore this will be 0.3. So if I said 0.3 plus what? But is it negative, or for this will be negative? So therefore it will be V0, it is equal to 0. So the V0 should now be equals to what? 0.3 what? 0.3 voltage. So how about the current? So let me start from here to what? To the ground. So therefore V0 minus what? Minus the current multiplied by what? By the ID. This should be as 0. So therefore the V0 should now be equals to this. What is the, but I have to say that, okay, it's the same thing as saying V0 minus what? Minus the current, which is ID, is the same thing as, because 1 multiplied by ID is the same thing as ID, but I have this, which is 0.3. But don't forget with the kilo, the resistance multiplied by what? By this diode, there is kilo inside. So therefore I have to say minus what? Minus ID, it is equal to 0. So therefore, when I have negative what? Negative ID should now be equal. So when this crosses the equal sign, it will be negative 0.3. By dividing both sides with negative 1. So therefore, for now, the value of this ID should now be equals to what? 0.3 what? milliamps because of what? Because of this kilo. So therefore, as you can see, the V naught it is 0.3, and therefore the ID, which is 0.3 what? Milliamps. So this is all I have for the what? For the question number 10. Question 11. Determine, also we are to determine the V naught and what? An ID in this figure below. So what the next thing that we are going to do, we have first identify this diode, is it on or off? So in the last video we talked about when two diodes, but gallium arsenide and silicon, all in the same direction, so are they going to move in the same point or not? So therefore the value of the silicon diode, it is smaller than what? It is smaller than what? What I mean is that the silicon, it has 0.7, so therefore why the gallium arsenide has 1. So 1.2, it is higher than this silicon. This silicon there, which is 0.7. So therefore they cannot pass, but only this silicon can pass. So therefore then we will off this. If we off this, this will be able to pass. So therefore we off this. But in this case we have the same thing, which is a silicon. So what are we going to do? Are we going to off one again and what? Use one, or whether you are going to go with them, or whether we are going to say they will off? So in this case they will what? All of them will on. All of them will on. As usual, this is on. So how can we do? So we can first come across here, come across and move here to find V naught, and we can come across here, come across and go straight to the ground, so that what? So that we can find the current, and we can also use from V naught here to find our current. What method did you prefer? So let's first use the V naught. Let's first use this and find our V naught. Let me drop this or rise it. It is rising, but let me drop it. If it is dropped, the rest will be what? Will be rising. So therefore it will now be plus what? Plus 0.7. Again, when it comes here, it will be plus what? Plus 0.7. When it comes and ends as this should now be what? Should now be, okay, sorry, I have V naught. I will add V naught, it is equal to 0. So this and this close, it will give me 1.4, and therefore I have minus 16 plus them. So plus what? Plus V naught, it is equal to 0. As usual, this and this, it will give me what? It will give me 14 point something. If I say minus 1.6 plus what? Plus 1 point, okay, minus 16. Minus 16 plus, sorry, minus 16 plus 1.4. So this should now be what? Negative 14.6 plus what? Plus V naught, it is equal to 0. The V naught will keep as it is. Therefore, the negative 14.6 will cross the equal sign, so it will now be 14.6 volts. So this is the voltage. So if I am to find the current, I'll just say this to here. So this should now be V naught minus 4.7 ID. I have this. So let me say this is the same equals to what? Minus 4. Because if I put negative 4, I will confuse some. So therefore this should now be V naught, it is equal to, when this crosses the equal sign, it will be minus. Okay, it will not cross the equal sign. Because of what? Because I'm dealing with this current. I'm going to find my ID. So I have to substitute this 14.6 minus 4.7 ID, it is equal to minus 4. So what is the next thing? When this crosses the equal sign, it will be negative. So I'll have minus 4.7 what? ID should now be equals to minus 4 minus again 14.6. Yeah. So this should now be minus 4.7 what? ID, it is equals to minus this. 4 plus 14, it will give me what? 18.6. But I'll have what? Negative sign. Divide both sides by minus 4.7 by minus 4.7. This will cancel this. Negative will cancel all negatives. So the ID should now be equals to, if I said this divided by 4.7, what should I go into get? 18.6 divided by 4.7. So this should now be what? 3.957 what? Milliamps. So, and also if you are to find the current using the second way, you can come across from here to here to here, off to this ground. So this is all I have for you for this 11th question. So here is the question that we are given. So we are going to identify the diode current, and therefore we are going to identify the V out and the diode current. So now how can we solve this kind of problem? So whenever you come across to this, the first thing that you're going to take a look is that you're going to take a look to the diode. The diode, are they on or what? Are they on or off? So if you take a look to these diodes, all they are on. Because if you can recall, the terminal positive, which is what the 10 voltage, it come across is the voltage distributed to the silicon diode and the gallium arsenide diode, and also we all know that the terminal that it distributed all are positive. So therefore these diodes, they are what? They are on. So after identifying the value of this diode, they are on, the next thing that you're going to do is that we are going to use the KVL. This is the upper loop. So you all know that we have a current here as what? Let's call the current I1, and also the current that is passing through here as what? As I2. So after then, the next thing that I'm going to do, when I use KVL, it comes across here and it will drop here. You all know that also if I use the lower loop like that, also the current will go down. But at the end, if these two current come in here, if these 2 points are coming to this point, I must to have what? I must to have I1 plus what? I1 plus I2. This shall now become I1, and therefore this shall now become what? I2. So let's solve this problem and see. So the next thing that I'm going to do, I have to use the upper loop like this. We all know the value of what? Of the silicon diode, which is what? The silicon diode, it is 0.7 volt, and the gallium arsenide, which is 1.2. so using the KVL, so there is rising and there is dropping. If you check a look to my last video for the diode circuit, I explained how rising and dropping it is. So I'll start with negative voltage. Already it is positive, but I'm going to put negative and all the rest will be positive. But if I use positive, the rest will be negative. So I have to say plus the value of the diode, which is 0.7, and I have to say plus the 2 kilo ohm. So I have to put the kilo aside, but I will use it. So I have to say 2I1 because I'm dealing with the first loop, the first upper loop. So I have to say plus what? Plus I will have, if I come down here, I will have what? 2 kilo ohm. So but this 2 kilo ohm, at this point I said I have I1 plus what? Plus I2. So if 2 into what? Into I1 plus I2, what shall I going to get? So if I distribute, I will get 2I1 plus what? Plus 2I what? Plus 2I2. So and also I have, so I have to, let me say 2I1 plus 2I what? I2 all equals to 0. So I1 and I1, they are in common, so I have to add them and they will become what? 4I what? 4I1. So you have to be writing it down. The next thing that I'm going to do, let me clean this. So if I subtract negative 10 plus 0.7, what shall I going to get? If I subtract this, I will get 9.3, but with negative. So negative 9.3. And therefore I have to say plus. If I say 2I1 plus 2I1, it will now become 4I1, and therefore plus 2I2 all should be equals to 0. So this is equation 1, but before saying this as equation 1, kindly write this down because I1 comes first. So I have to say 4I1 plus what? Plus 2I2, which shall now be equals to, when the negative 9.3 causes a constant, it will now be positive. So I'll have 9.3. So this is the first equation. Please write it down because I didn't have enough of space. The next thing that I'm going to do here is that I have to take a look to the lower loop, that I will use the same KVL method. So the next thing that I'm going to do here is that I have to again use 10 voltage, and therefore plus the 2 kilo ohm, which is 2I1. And don't forget, I said, okay, I have to say I2 because I'm dealing with with the low values. Don't forget, I said I will keep the kilo aside, and at the end I will use it. So, and then I have to say plus, I have 2 kilo ohm here, so I have to only use the Q because I'll use the kilo later. I'll use the kilo. So I have I1 and I2. I will say I1 plus plus I2, all should be equals to 0. So minus minus 10 plus 1.2, I will get negative negative 8.8. So I have to say plus, if I distribute this, I'll get 2. If I distribute this bracket, I'll get 2I1 plus plus 2I2. And don't forget, we have 2I2, so they will sum together, and I will end up with 4I2. So I have to say 4I2 plus 2I1 equals 0. The next thing that I'm going to do here, I have I1 first. So 2I1 plus plus 4I2 should now be equals to negative 8.8, should cross the equal sign, and I will get 8.8 as my equation 2. So don't forget to keep down this equation 2. So let me keep down equation 1. Equation 1, if you will recall, 4I1 plus 4I2, which is equals to 9.3 as my equation 1. 9.3. So an equation 2 will now be 2I1 plus 4I2, which is equals to 8.8. So guys, you can use the Cramer's rule, and also you can use the substitution method. So after then, you are going to find I1. If I use the Cramer's rule, I already find the value of delta as as 12, and the delta 1, after putting the output in in the first column, I get 19.6. And for the delta 2, after putting the output at the second column, I get 16.6. So after then, the next thing that you're going to do is that, I hope you write it down. I hope you write the value of the value of this delta and delta 1 and this delta 2. So now we are going to find the current. So to find the value of I1 is the same thing as as delta 1 over the normal delta. So if you divide, you're going to get I1 should now be equals to 1.633. Because of that kilo, so this should now be milliamps. And also for I2 is the same thing as the delta 2 over the delta. So I2 should now give what will be the value of I2? Let me put the value of I2 here. The value of I2 after dividing this, it is equals to 1.383 milliamps. So this is the value of I2, and this is the value of the value of I1. So the next thing that I'm going to do here is that, so as you can see, the current through the first and the second diode, the first diode carries 1.633 milliamps, and the second diode carried 1.38 milliamps. The next thing that I'm going to find is the V out. So how can I find the V out? To find the V out, as you can see, V, it is equals to IR. So the next thing that I'm going to do here is that I'll just say V naught, it is equals to I1 plus I2 multiplied by this 2 kilo ohm. So this 2 kilo ohm. So as you can see, I1 which is 1.633 milliamps and I2 which is 1.383 milliamps multiplied by 2 kilo. You're going to multiply with the milliamps and what, and also with the kilo. So at the end, V naught, it is equals to 6.03403. I'll leave it at 3. So this is my V out. So this is the end of this question. I hope you get it more. Don't forget to subscribe to this YouTube channel. If this video is more helpful to you, kindly consider subscribing. Press the bell icon so that you'll be notified immediately if I uploaded any content.